Imagine you wake up in a completely unknown world. No language, no labels, no instructions, only patterns. You see shapes, colors, sounds, motion, but nothing has meaning yet. A circle is just a curve. A face is just pixels. A voice is just vibration. Now imagine someone shows you 10,000 examples, and slowly, patterns begin to repeat. That, surprisingly, is how artificial intelligence begins its journey. Not with knowledge, not with understanding, but with exposure. Today, we're going inside the learning process of AI, not with equations, not with jargon, but with a visual story. By the end of this series, you'll understand how a machine goes from zero knowledge to recognizing images, language, and decisions. And the twist? AI doesn't learn like a brain, but it also doesn't learn like a program. It learns like a system that rewrites itself. Let's open the black box. Most people imagine AI learning like this. You give a machine rules. The machine follows rules. Done. But that's not learning, that's automation. A calculator doesn't learn addition, it executes it. A traditional program follows if-then instructions written by humans. Every decision path is predefined. AI learning is different. Instead of writing every rule, we build a learning structure, then let data shape it. Think of it like this. Normal software equals a recipe. AI system equals a chef apprentice who learns by tasting thousands of dishes. One follows instructions. The other adjusts based on results. That difference changes everything. When an AI model begins training, it knows nothing. Not a little. Not almost nothing. Literally zero useful understanding of the task. If you show it a cat image on day one, it has no idea what a cat is. It doesn't even know what animal means. It only sees numbers because every image becomes numbers inside a computer. Pixels numbers. Sound numbers. Words numbers. AI does not see, it measures. Picture a giant spreadsheet where every pixel brightness becomes a value. That's the machine's reality. So how can something that only sees numbers learn meaning? Through pattern pressure. Let's build a mental scene. You're shown 50,000 images, each labeled cat or not cat. At first, you guess randomly. Wrong, 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 wrong. But after each guess, someone tells you the correct answer. Slowly, your brain starts noticing. Cats often have triangular ears. Cats have certain eye spacing. Cats have whisker-like lines. Cats appear in certain shapes. You don't memorize each image, you detect repeating structure. AI does the same, but through math instead of intuition. It builds pattern detectors, tiny adjustable filters that respond to certain shapes or relationships in the data. Early detectors notice edges. Later detectors notice textures. Even later detectors notice object parts. Not because we coded that, but because repeated correction forces it to evolve those detectors. Learning equals repeated guessing plus repeated correction. That's the engine. Let's visualize the simplest learning machine. Imagine a wall of adjustable knobs. Each knob affects how strongly the system reacts to certain input features. Input comes and flows through knobs, produces an answer. At the start, the knobs are random. Output is nonsense. But after each mistake, the knobs twist slightly. Tiny adjustments, millions of times. Eventually, the knob settings become tuned to reality. This is what a neural network really is. Not a brain copy, not consciousness, just a layered system of adjustable parameters. Millions, sometimes billions, of adjustable knobs. Training is knob tuning at scale. Why mistakes are required? Here's a counterintuitive truth. AI cannot learn without being wrong first. Mistakes are not failures, they are signals. Each wrong answer generates a measurement called error, the distance between guess and truth. Error is like heat on metal, it reshapes the structure. No error, no adjustment. No adjustment, no learning. That means a perfectly correct AI on day one would actually be impossible, because it would have no correction signal to shape itself. Learning requires friction, and AI experiences friction as mathematical loss. Error as a landscape. Imagine a huge mountain landscape covered in fog. You're dropped somewhere randomly and told, your goal is the lowest valley. You can't see far, only the slope beneath your feet. So you step downhill, measure again, step downhill again. That's how AI reduces error. It navigates an invisible error landscape, adjusting parameters in the direction that reduces mistake. This process is repeated millions of times across data examples. Each step is tiny, but tiny steps scale. From random chaos, structured intelligence. From pixels to features. Let's zoom deeper. Suppose the AI is learning images. At first layer, detectors respond to edges. Second layer, combinations of edges. Third layer, shapes. Later layers, object parts. No one programs these stages directly. They emerge from pressure to reduce error, like crystal patterns forming under physical constraints. This is why AI learning feels magical. Structure grows from correction, not instruction. Not rules, responses. Training versus using AI. Another common confusion. People think AI keeps learning while you use it. Usually, it does not. There are two separate phases. Training phase, massive data, massive correction, massive adjustment. Inference phase, model is frozen. It only applies learned patterns, like studying versus taking an exam. During exam time, no learning, only answering. Training is expensive. Using is cheap. That's why AI training happens in data centers, not on your laptop. Why repetition matters. A human may learn a pattern after 5 examples. AI might need 50,000. Because AI doesn't assume meaning, it measures correlation strength. It needs statistical confidence. Repetition increases certainty. Think of it like sharpening an image from blur to clarity. Each example adds resolution. One example equals noise. Thousands equals signal. Learning is signal amplification. Building blocks of learning. Every modern AI learner depends on 3 ingredients. Data, examples of reality. Structure, adjustable model. Correction, error feedback. Remove anyone, learning collapses. Data without correction equals memorization. Correction without structure equals chaos. Structure without data equals emptiness. Learning exists only when all 3 interact. Like fire needs fuel, oxygen, and heat. Visual summary of part 1. Let's compress the journey you just saw. AI starts blank. Sees only numbers. Guesses answers. Measures error. Adjusts internal knobs. Repeats millions of times. Patterns emerge. Structure forms. Recognition appears. No understanding yet, only pattern alignment. But alignment becomes capability. And capability looks like intelligence. But how exactly are those knobs connected? What structure allows millions of adjustments to coordinate? That's where we go next. Because inside AI learning is a layered architecture, inspired by neurons but engineered in math. And once you see that structure, you'll never see AI outputs the same way again. What if intelligence is not about thinking but about layered signal flow? In the next part, we open the architecture itself and watch a neural network build perception from scratch. The layers are waiting.